All right, this is Chapter 1, Section 2, talking about measurements in our experiments, and we're looking at units and dimensions. So, we most of the time will just be using the System International, which means using units like kilograms and meters instead of the units that are typically used in the U.S., which for the same things would be pounds or feet. Okay. And it's called System International because internationally, with the exception of the U.S., everybody has agreed to use these units, but scientists in the U.S. do use these metric units as well. So there are two basic types of units. There's base units and derived units. So base units are just units that you directly measure, like length, mass, and time. You can't break them down in any way. Derived units were created as a way to serve as a shorthand or a shorter way to write a set of units often found together. So one example is force. Force, we use the unit of Newton, but it is a derived unit because 1 Newton equals 1 kilogram meter per second squared. That should say squared, not times 2. Okay. So basically, scientists like to be efficient, so they took all these units, and instead of writing all of those every time, they just shortened it into the Newton. Scientists do always like to be efficient, so sometimes numbers are too large or so small that writing them out entirely takes up a lot of space. Nobody likes to waste space. So scientists will often use scientific notation or prefixes to help reduce the space used to write. So just as a reminder, if we had the number of 584 million, if we used scientific notation to write this out, we would write it as 5.84. We'd count all our zeros all the way down, and there's 8 of them, so we'd say times 10 to the 8th. And that is scientific notation. Prefixes are like the ones you see here, and this is in page 12 of your text. And you guys will need to memorize the powers of -9 to 9. So that starts here with -9 at nano. You'll need to know nano, micro, milli, centa, deci, deca, kilo, and mega, and the last one is giga at 10 to the positive 9. Make sure you recognize the prefix and the abbreviation. So let's look at a real quick example of that with our same number that we had just a second ago of 584 million. So we already know if we write that in scientific notation, it's 5.84 times 10 to the 8th. And now if we want to use a prefix, we just need to look for a power of 6, okay? Or of 3, excuse me. So here, 8 minus 6 is 2. So we're going to rewrite this as 5.84 times 10 to the 2. And now where this other 6 zeros went, essentially these ones here, we can write it as the prefix. So for positive 6, we get the prefix mega, which is capital M. You need to know how to say it. And then if, say, we're talking about a distance, maybe we're talking about meters, I'm going to add meters here. Okay. So you should be able to recognize the prefix next to the unit so that you can see them together and know that this means millions of meters. If you wanted to simplify this even more, you'll commonly see it written out just as the whole number instead of scientific notation and this, as long as the number is not too large. So the last way that you could write this is you could just say 584 megameters. And that is the simplest way. Dimensions. The words dimension and unit are very, very similar. Okay. So dimensions are measurements like time, length, and mass, but sometimes they have different units. So we just talked about the international system versus the US system. So for length, you have the dimension of length, but you could use 2 different units. You could use meters, or you could use feet. Okay, so meters and feet are units, but length is a dimension. Okay, so when solving physics problems, dimensions must match. Okay, so if you're solving for acceleration, which the equation for acceleration is equal to distance divided by time squared. Okay, and if you're solving for it, okay, you need to make sure that if this equation in our units, we're using the international system, so if our distance in this case should be meters per second squared is the units we want to get, we need to make sure that we're using meters and not kilometers, not feet, nothing else, just meters. Okay. We also want to make sure all of these are length, right? So if the dimensions must match, we wouldn't want to accidentally use kilograms, which is a measurement of mass, when we should use kilometers or meters. Next, the units must match. So this goes with just what I was saying. If we're calculating acceleration, the units need to be meters per second squared. So you need to not use feet. Okay, you'd have to convert it. You can't use inches. You can't use kilometers. Okay, that's a similar unit, and that brings us to our next rule. Units must have the same decimal prefix. Okay, so again, acceleration is meters per second squared. So no kilometers, no megameters, no nanometers. You'd have to convert all of those into the same decimal that your equation requires. So that's it for this short video. Go ahead and make sure you take a look at the video on accuracy and precision, as well as on significant figures.